In Lesson 3-4, we will discuss exponential and logarithmic equations. In video 3.4.5, our learning target will be for students to be able to solve an exponential equation. In example 5, we're asked to solve 3 raised to the 6x minus 3 is equal to 2 raised to the 4 minus 4x. And we're asked to round our solution to the nearest hundredth. Now, like in the last video, in video 4, anytime we are solving for x, and x is part of our exponent, hence solving an exponential equation, we are going to first start out by taking the logarithm of both sides. Now, in this case, it really doesn't matter if I use a logarithm or a natural logarithm because neither of our bases are e or 10. So I don't care which logarithm we use. I'm going to just use common log. Generally speaking, I only use natural log if one of our bases is e, which in this case, our exponential functions are base 3 and base 2. So I'm going to use a common log on both sides to begin the problem. Forgot to take the logarithm there. So I'm going to take the logarithm of both sides. What I do to one side of an equation, I have to do to the other as well. Now, why this logarithm is going to help me is because I can apply the properties of logarithms, and these exponents can be brought out in front on both sides, and I get 6x minus 3 times log base 10 of 3 is equal to 4 minus 4x times log base 10 of 2. Now what I'm going to do on both sides is I'm going to multiply both sides by, actually distribute on both sides. I'm going to take this log 3 and figure out what its value is. Log base 10 of 3 is 0.477 1212547, and that's equal to 4 minus 4x, and I'm going to multiply that by log of 2, which is log of 2 is 0.3010299957. Now, what I'm going to do on both sides is I'm going to distribute that 0.477 and distribute that to both the 6x and the negative 3. So if I do that and multiply log of 3 times 6, that I'm going to round here and say 2.86x minus, I'm going to multiply log of 3, which was this 0.477 number, and I'm going to multiply that by negative 3, which gives me 1.43 if I round to the nearest hundredth. On the right side of the equation, I'm going to distribute that log of 2 to both the 4 and the negative 4x, which gives me 0.602 minus 6.602x. Now my goal here is to solve for x, so on the next slide I'm going to go ahead and continue solving this equation and get x by itself. So in the last slide we had the equation 2.86x minus 1.43 equals 0.602 minus 0.602x. Now I'm going to finish solving this equation for x. I'm going to start by adding 0.602x to both sides of the equation. On the right side, the 6.602x's cancel. If I add 2.86 and 0.602, I get 3.462x minus 1.43, which is equal to 0.602. And I'm going to add 1.43 to both sides. And I'm going to get 3.462x equals 2.032. Those cancel out. And I need to finish solving for x, and I'm going to divide both sides by 3.462. Division undoes that multiplication. We are multiplying the x and the 3.462. So those will cancel out, and I'm left with x equals, to the nearest hundredth, 0.59. And I should say is approximately 0.59, not equals 0.59, because we rounded. Thus, x cannot equal exactly 0.59. And you would figure that out by plugging 0.59 into your original equation. It's not going to equal out exactly on both sides, but it should be pretty close. In example 5, guided practice, you're asked to solve the equation 4 raised to the x plus 2 is equal to 3 raised to the 2 minus x, round to the nearest hundredth. You have 4 choices, A, B, C, and D. So at this time, I would like you to go ahead and solve this exponential equation using logarithms, find the solution for x, and then press submit.